Okay. Yeah, we were talking about SA engine almost 4 to 5 classes, because basically how to make the engine electronically controllable, because that is the main prime source of energy source for vehicle movement, any autonomous vehicle, any vehicle, because engine is the prime. That's why we are talking, because same thing we will now today we will see about how the diesel engine is controlled, correct? Because it is similar to that, a little bit variation only. So yeah, so here we talked about knock control. Did we talk about knock control previously? I think we are talked knock sensors, all those things, because I told you you have to run the petrol engine close to knock condition, because I told you that gives maximum thermal efficiency. Types of sensor we are talking. This is the control system for knock control, how it works, correct? Already I told you, just so you can see it. Then one minute. There is a small thing I have to leave. Okay, knock control, I told you that again, it is similar to the fuel injection, correct? Because you need to give the, what is the spark ignition angle, correct? Which is before TDC, that is based on engine speed and the engine load, the where the spark should be given, correct? When we talk about the, correct? This is okay. So this is the spark where the spark is given, correct?
Hello, sir.
Yes, please.
We can see the desktop, but the presentation has been minimized, I think.
Presentation minimize. No, it is in full screen. Just a minute. Just a minute. I will see.
Sir, after your setting change, it is not visible.
Okay, 1 minute. Okay, okay. 1 minute. Display setting. So this means. Now?
Yes, sir. Visible.
Okay, thank you. Okay, so because similar to this one, we know that engine speed, you have to create a map. Already I told you that map I showed you in the quickly just show. Yeah, this is spark timing map, correct? Where you have to give this spark. This should be mapped using this, and that's what the input, correct? In the actual engine, when you connect the, if you want to control knock control, correct? So this is engine speed sensor. This is the engine load, correct? Of course, uh, there's no need for throttle position, correct? Engine load and engine speed, primarily engine speed and also engine load. The sensor, based on that, the spark advance angle will be done. This is called base, correct? Then we wanted to control the closed loop, again, just like a fuel injection, injection duration, correct? We saw the previous slide where we wanted to control the closed loop air control, correct? So this is the base fuel, correct? Pulse width using feed forward lookup table. The second one is closed loop air control. This is using PID control, whatever maybe PID control or PA control different. This is closed loop. This is closed loop control, can be a PID control. Open loop control, this is open loop. Correct? Lookup table base. Correct? So you'll be able to final control. The same thing is done in knock control also. But of course, you need a knock sensor. Correct? So you can use any one of the knock sensor, what we are told, microphone or in-cylinder pressure or the vibration signal coming from the this sensor. Correct? Piezoelectric base washer type. Correct? So this gives this kind of signal. Correct? So using this signal, if engine is knocking, if there's no knocking, you can see that this washer type sensor provides very small signal. Correct? In the order we are talking about acceleration measuring, because the vibration sensor measures acceleration. So you can see that very small value. Correct? But if slight knocking is there, you can see that there is a small amplitude compared to this. Correct? Y-axis amplitude. Here no knocking. Maybe a little bit is there, very this one normal combustion, and here you have knocking. We want to run your engine close to in this region. Correct? We know that that's what I told you. If you run your engine close to knocking, light knocking, thermal efficiency is more. But if knocking becomes more, you can see that the amplitude is very high. Correct? The amplitude is high. Correct? So you should not run. That's what I told you. Correct? For that, you can give a feedback. Knock sensor detector. Correct? This is sensor. Correct? From the engine, you put your washer type, any of the sensor, give this one. So this will add. So basic, this one, for example, at 3000 RPM. At 3000 RPM, for example, 30% throttle. Correct? Engine is running. Correct? For that, the spark advance and the spark, I say a short form, I say SA. Spark advance angle is 30 degree before TDC. Correct? Before TDC. Correct? So you are giving spark. So combustion happens. Correct? Combustion happens. By then the piston reaches. Correct? Piston was somewhere here. Correct? This is my cylinder. I am giving a spark. Correct? Piston is moving up. When this was here, this is the TDC position. Correct? Piston is moving up for the compression. Correct? Is compressing this one. And when it is 30 degree before, correct? 30 degree before TDC, this position, correct? So because crank, we are talking crank angle, correct? 30 degree before TDC, you give a spark. So the flame start propagating, proper combustion happens. Why we need this? I told you, because combustion takes some amount of time, correct? To combust the air fuel, petrol, correct? Gasoline air fuel mixture, it takes a finite amount of time. Please note that it takes finite amount of combustion time, correct? Combustion time. That means, but the how much time? Maybe 3 to 4 milliseconds or 2 to 3 milliseconds. That means spark you are giving. Here the ignition starts, then it is propagating, correct? The flame is propagating. By the time the piston comes to TDC position, correct? This position, at least 50% of the fuel should have been, 50% of the fuel air mixture should be burned. Fuel air mixture should have been burned, correct? That is the rule, correct? So then, if the 50% fuel air is burned, you will get maximum pressure. Maximum pressure, correct? So here, so then you will more the pressure. P is more torque, correct? Torque is more because pushing down. There's this one. So engine develops maximum torque. So that means the thumb rule says that thermodynamics rule says that if the piston comes to TDC during compression stroke, by the time piston reaches TDC, at least 50% air fuel burn, not more than that. It's not less than that. So if you make that to do that, you have to give the spark in time. Why? The combustion, the 50% fuel air mixture has to burn. Correct? It takes finite combustion time. Correct? Combustion cannot happen 0 time. In the universe, nothing can happen in 0 time. Correct? So it takes some time. It can be 1 or 2 milliseconds, something like that, depending upon compression ratio, the air fuel ratio, all these things matter. But average is, say, for example, it is say 1 millisecond or 1.5, something like that. I'm just so that much time you have to give. Correct? Now, if engine is running at the 3000 RPM, correct? We know that the stroke time is 2.5 millisecond. Correct? The compression stroke takes 2.5 milliseconds. Correct? That is from BDC. Piston was moving from BDC to TDC. Correct? BDC is moving up, compressing the air fuel mixture. So that takes totally 2.5 milliseconds, because we know that 3000 divided by 60 gives 50 RPS. Last class I talked about this 50 RPS within 50 hertz. The cycle time for 720 degree, because you know that combustion suction, correct? It goes combustion, then for this one, then exhaust. This is 720 degree, correct? That means 2 crank cycles, 363, 2 crank angle rotation equal to 1 engine cycle in 4-stroke engine, correct? In 4-stroke engine, correct? So that means each stroke takes 180 degree. For traveling 180 degree, total time is 1 divided by 50, correct? That's nothing but 20 milliseconds per stroke. Compression, all those things divided by 4, correct? It is 5 milliseconds. Sorry, it is 5 milliseconds. I think I made some mistake somewhere. 2.5. It is 5 milliseconds. Total time available is 5 milliseconds. So 5 millisecond duration for 180 degree travel of the crankshaft, correct? Or piston moving from BDC to TDC. And we said that then you can find out how many milliseconds or microseconds takes for the piston crankshaft rotation piston movement from BDC to TDC, correct? So after that, we have to give the spark 30 degree before, 40 degree before. Why? This time is fixed, correct? We know that 5 milliseconds I will 3000 RPM. If I say the combustion time is 2 milliseconds, correct? 2 milliseconds the combustion time for this speed, all those things, for example, then we know that when by the time the TDC, the time needed for the piston to move from the location where you are giving spark, correct? Where you are giving spark, I am giving spark here, correct? You can see that I am marking with different color. I am giving spark here, correct? This is my TDC, correct? So this time, this is, I say that should be, this time should be equal to 2 milliseconds, correct? 2 millisecond time is needed. That means you have to give spark before that. That means accordingly you have to calculate what is the angle. That is the spark SA. Spark, it is called as spark advance angle. It is called as spark advance angle, correct? Advance angle, I say SA before TDC. This is a TDC location, correct? So that depends on engine speed. For 3000 RPM, you say this one. That means if you go to 6000 RPM, correct, you have to give something around 60 degree, correct? So for example, it is 20 degree, correct? If I say that this is 20 degree, you have to give 42 twice. If it is 12,000 RPM, you have to give 120 degree. But generally, we don't go that much. Generally, spark advance will be in the order of 60 to maybe, correct? Maximum 60, generally it will be 50 to some 20 degree, 10 degree, correct? Before TDC. That's how you have to do. For that, you have to use the knock sensor and see that control, correct? Spark should be given such that knocking doesn't happen, correct? How you know that knocking doesn't happen? By sensing the vibration signal of the cylinder, correct? Cylinder vibration or the sound or in cylinder pressure. You can use any one of the sensor. That is the sensor which gives whether knocking is happening. So you are how will you control knocking? Knocking can be controlled by varying the SA, spark angle, correct? One way of controlling knocking in SI engine, controlling spark angle. So these were closely with. Now we will see what you call as this is over petrol engine or gasoline engine. We will see common rail system. In common rail, the diesel engine. In common diesel engine also we are talking injection, correct? Please note that in the diesel engine, from the beginning it is a fuel injection only. Even the first engine, correct? So it is called compression. It is called a CA engine. All of you know that it is called CA engine. What do you mean? Compression ignition engine. A student who have done ICE engine will be a mechanical student. Maybe other student may not do. Compression ignition engine is called is nothing but your diesel engine, because that fuel is diesel fuel, not petrol. Okay, so that is called as CA. Short form is CA engine. In CA engine, if you see that again same as your this one petrol engine only. Okay, you have your cylinder, correct? Inside that there's a piston moving. It is connected by a connecting rod to a crank mechanism, correct? This is your crank mechanism. This is my piston. Right. So this is the combustion chamber, same as your petrol engine. There's no difference. Okay. So of course this is closed. Correct. This is totally enclosed, and nothing can go in. Then you have a inlet port and you have a valve. Right. This is inlet port, and you have an exhaust port. Of course, there's a valve, correct, which will open, and you have an injector. No spark plug, correct? So here, yeah, already shown here, correct? So this is the injector, diesel injector. So high pressure diesel is supplied to the injector, and inject is controlled electronically, just like this one. It is a solenoid based. Inject is solenoid based. Previously we had mechanical injector. Now for the latest generation, this one we have solenoid injector, correct? So so here what happens is, during suction stroke, piston is going down, correct? The air will be sucked in. This is air. Please note that the fuel is not mixed when air is sucked in. That is the difference. In petrol engine, while air is sucked in, fuel will be injected at the inlet port. So the petrol will evaporate and mix while in the suction stroke itself. In the suction stroke, as the air is entering, fuel is injected inlet port. That's what we said PFI, port fuel injection system. Correct? So fuel is injected and the fuel will mix with the air, and the air fuel mixture will enter into combustion at the end of the suction stroke. Then compression happens. Correct? Fuel air mixture is compressed, but then you give a spark. But in diesel engine, totally reverse. There's no spark plug. Combustion start what you call self-ignition. It is called as self-ignition. Correct? That is a diesel engine. Diesel fuel automatically ignites when the air temperature inside the combustion chamber increases beyond, say for example, 320 degree or 350 degree. Correct? That is called self-ignition temperature. Self-ignition of temperature of the diesel is maybe around 300 to 320 or 350 degree. Correct? But in case of petrol engine, correct, gasoline, petrol self-ignition temperature is above 520 degree, approximately self-ignition temperature of petrol is approximately around 500 degree. This is approximately around 300 to 350 degree diesel. Okay. Okay. In diesel engine, during suction stroke, air alone is sucked in. Correct. So the piston is in down position. Correct. I say that it is down position. The entire combustion chamber is filled with just air. Correct. No diesel. Then the inlet valve closed. Then the compression stroke starts. Correct. The compression stroke starts. The piston start moving up. Correct. The piston is start moving up, compressing the air. It is just compressing air. No fuel is there. When the piston comes, just before it is like a petrol engine, when the piston is somewhere some 30 degree before, 40 degree before, when the piston comes here, correct, come here during the compression, correct. So then what you do, you inject the fuel, diesel fuel is injected, sprayed at very high pressure, correct. In diesel, fuel injection is around, generally in old generation, I'm talking about the old generation diesel engine, which is 20-30 years before, the injection pressure was 300 to 400 bars or 200 to 350 bars something, correct. 400 bar pressure, correct. So you are spraying the fuel at 300 bar. In already I told you, in PFI engine, what is the fuel injection pressure? 5 to 6 bar, correct. But why? Even because the low pressure fuel injection, petrol, the petrol liquid fuel will be dispersed as small droplets, correct. The droplets may be 50 to 100 microns, something like that, 20 micron, 50 micron, depending upon the pressure, correct. So, but petrol can easily, gasoline can easily evaporate at room temperature itself. Normally, even if the liquid pump fuel puddle, correct, if air is going at 30 degree, you can see that it can evaporate. Even at 30 degree, fuel is in liquid form. We put it in a small open jar. If you blow your air from your mouth, it will evaporate, because 30 degrees it can evaporate, not fully. But if you disperse it as a PFI 5 bar, through injector. That's why from carburetor we come to fuel injection. Correct? Instead of fuel, liquid fuel, it is the bigger high pressure. It is dispersed as droplets. Correct? Maybe 50 to 100 micrometer diameter. But this on which if you send the air, say 30-degree air, that's what fuel injection. It can heat more than 80%, 90% of the fuel droplets will evaporate, enter into cylinder, and inside cylinder also the fuel air is mixing during compression. And end up just before it comes, you're giving spark plug, correct? Then it starts. But in diesel, it is totally reversed, correct? So another thing is in petrol engine, the compression ratio is 8:1 or 10:1 only, correct? So that means during the end of the compression stroke, the temperature inside the petrol engine may be around 300 degree, correct? Or 250, maybe 200 to 250 degree only, not more than that, correct? Because compression ratio is around maybe reach, correct? So because of that, the air compressor, fuel air mixture reaches 200, 250 degree. But what is self-ignition temperature in petrol? I told you 500 degree, correct? That is his fundamental property, physical property, chemical property of petrol. Only when the temperature, the air surrounding the petrol reaches 500 degree, even without spark plug, it will start igniting, burning, correct? That is called self-ignition, above 500 to 520 degree. But in petrol engine, since compression ratio 8:1, the compressed air fuel mixture reaches only 200 to 250 or 270 degree. So that temperature much lesser than the self-ignition temperature of the petrol, correct? So combustion doesn't happen. That is why you have to give spark plug. Like a spark plug creates 10,000 degree, 20,000 degree because ionization. 10,000 so combustion starts. But in case of diesel self-ignition temperature around 320 to 350 degree, and the compression ratio of the diesel engine is 15 to 18, 15:1 to 18:1, something like that, correct? Because of that, the compressed air, end of the compression stroke, the inside the compressed air reaches around 450 degree or something, 400 to 450 degree centigrade, correct? Then just before the piston reaches TDC, just like a spark ignition engine, what you are giving? You are injecting fuel. You are not giving spark. Fuel itself introduced into the combustion only some degree before the TDC during compression stroke. So it is sprayed at 300, 400. In case of common rail diesel injection, that's what we are talking. We are about 1,500 bar to 2,000 bar. Extremely high pressure, correct? So then what happened? Fuel will disperse inside the combustion chamber through the injector nozzle. Injector nozzle will be again micron size, correct? 50 micron, 25 micron, 30 micron, something like that, correct? So when the high pressure fuel injectors are such a small opening, the fuel will be dispersed in the order of 5 micron, 10 micron droplet, very small droplet, minute droplets, correct? The droplets, the diameter will be maybe 10 to 50 or 20 micron within the range, correct? Then because the compressed air is already around 400 to 450 degree temperature, the droplets will start evaporating, instantaneously start evaporating, correct? Once it evaporates, the temperature is sufficient, because please note that whether diesel or petrol, any liquid fuel will not burn unless it becomes a vapor, correct? Combustion is nothing but fuel vapor, that is fuel molecules, individual molecules, HC, will get in contact with oxygen molecules at high temperature and high pressure. Then only combustion will happen. High temperature is required, correct? High temperature here achieved by compression. By diesel engine, there's no spark plug. You are compressing the air 15:1, 18:1. So the end of the compression stroke, the inside the compression, the air alone is there, no diesel, correct? So that temperature around 400 to 450 because high compression ratio compared to petrol engine. The air is very high. Now inject the fuel at very high pressure, correct? Compared to 5 to 10 bar and port fuel, and GD engine, gasoline direct engine, correct? We didn't have time to talk about it. I pass over with you. So that we inject the fuel directly inside the combustion chamber in the order of 30 to 40 bar or 25 to 30 bar. Compared to that, diesel fuel is 1,500 bar, correct? So the fuel is finely atomized, correct? Because atomization, the fuel droplet become very fine. Why? The fuel should completely evaporate, because diesel fuel doesn't evaporate easily compared to petrol, correct? Finally, particles, droplet size and high internal combustion chamber temperature because high compression ratio around 450. The diesel fuel from liquid, even the small droplet will evaporate and it mixes with the air. Once it mixes with that, it finds the oxygen molecules nearby, and because high temperature, ignition happens. So each fuel, correct? If I say that this is my cylinder, compress this one, there are fuel this one, each one will start burning, correct? So this is called self-ignition. Diesel fuel automatically ignites because high temperature of the air inside the combustion chamber, which has so the O2 molecules will combine with C and it will form CO2. We call it as oxidation and combustion. So that's how the diesel engine works, correct? So there's no need of a spark plug because high compression ratio. This is a diesel engine working, from the basic diesel engine, correct? So now the latest generation of the diesel engines are nothing but what we call a common rail diesel injection systems. They call CRDi, correct? If you see the many SUVs, correct, cars, diesel engine, this one, or trucks, bus, backside sometimes they put what is CRDi, you can see that, correct? CRDi is nothing but common rail diesel injection. What do you mean by common rail? Because again, like any other diesel engine, there's this injector for cylinder. If in the old generation, if you diesel engine, for example, you say ambassador car, diesel engines are there for last 30-40 years, or truck, Ashok Leyland, any truck, bus for last 100 years or 70 years or 90 years, it is there. You say 4-cylinder engine bus, correct? So that means you will have 4 injectors, correct? 4 injectors, and there will be fuel tank, correct? Fuel tank, in which diesel from this it comes to what you call directly to pump, correct? That is called fuel pump. It just sucks the fuel and sends to individual injector, correct? So for example, 3 cylinders, there are this one. So whenever fuel is needed, the injector will automatically open. They are mechanical injector, correct? So they have a mechanism to compress. See, this fuel is a pressure 1 bar pressure, correct? The pump sucks the fuel from the tank, that is diesel fuel, correct, and sends to individual injector. Individual injector, there's a mechanism to compress the fuel, diesel fuel, up to what? That up to 300 to 400 bar. This is called individual injector or unit injector, correct? This is called as individual injector or unit injectors. Correct. It is single cylinder engine, only one cylinder will be the one piston, one injector. If the multiple engine, diesel, say bus engine, it can be 6 cylinder, correct? So 6 injector will getting fuel pump, it comes. But inside this one, there's a mechanism to compress the fuel, diesel fuel, which is 1 bar to 300 bar, correct? Inside each injector, correct? They're called unit injector. This is what used for last 70, 80 years. But there's a problem with unit injector because when the fuel injector opens, the fuel pressure drops, correct? The fuel pressure drops from 300 bar to less. When injection is over, when the injector is trying to close injection, correct, to injecting particular quantity of fuel, the pressure inside the pressurized fuel inside the injector, the pressure comes to 100, 150 bar. If pressure drop reduces, then the atomization doesn't happen, correct? When the pressure is less, the injected fuel, this one, will not become atomized, smaller droplets. It's that fuel itself will go inside with a bigger droplets. The droplets will become bigger if the pressure drops inside the injector. Because of that, what will happen is all the fuel will not burn, because even though it starts by individual droplets is burning, if the droplet size is bigger, correct, all the fuel will not evaporate, diesel fuel, correct? But now, end of the power stroke, some amount of fuel is not burned, partially burned. The droplets will be partially burned, correct? So the partially burned fuel will come as what we call the smoke particles. We call it as smoke particles, correct? You will see that in petrol diesel engine alone, in the exhaust pipe, which we call a tailpipe, you will see black color smoke will be coming, correct? Black color smoke will be coming, which is called smoke particle. In petrol engine, you'll never see that this kind of black particles coming out, correct? Because the evaporates, even the unburned fuel comes as a gaseous form, which is called hydrocarbons, correct? It comes in the vapor form only in petrol engine, unburned fuel. But in case of diesel engine, unburned fuel will come as a particulate, smoke particles. That means the fuel is burned partially, diesel fuel is burned partially, the core has not burned because you have a droplet. The top layers are evaporated during the combustion process, but some amount of fuel, maybe for example 100 micrometer diameter is the droplet size. It maybe 80% low. Remaining small percentage will become partially burned. Correct? The partially burned fuel. Correct? That's what we call the smoke particles. Correct? In correct terminology in the IC engine is called particulate matter, PM matter. Correct? So that's what coming in diesel engine. Now, if this particulate matter partially burned carbon, correct? Hydrocarbon, this one, if you inhale, it goes inside your lungs, correct? And it deposits inside, it can create cancer. That is another, that is the problem with the diesel engines, correct? So in diesel engine, you get NOx, nitric oxide formation, because diesel engine combustion temperature is very high, correct? Generally, combustion temperature is more than 1200 degrees centigrade, correct? Because high compression ratio. Apart from that, and if fuel is not burned properly, if you don't give sufficient time for burning the fuel, correct? Then what will happen? You will get particulate matters. You will not get HC and CO emission more in diesel engine. In diesel engine, the HC and CO emission will be very less, compared to very less, correct? Compared to petrol engine, correct? NOx formation happens only you are running very lean engine, correct? But in case of diesel engine, NOx is the main problem. HC, CO will be very less. Of course, you will get particulate matter, correct? NOx and particulate matter very main problem in diesel engine. In petrol engine, HCCOA and NOx. HCCOA is main, NOx also is there. So now, if we want to reduce the particulate matter, correct? Less particulate matter, what you have to do? You have to inject the diesel fuel at very high pressure so that the fuel, diesel fuel liquid will become much smaller droplets, correct? Smaller the droplets. So if the injection pressure is higher, the injection pressure is higher, right? What is this one? The diesel fuel droplets injected inside the engine will be smaller in diameter. Injected in combustion chamber becomes smaller. So that's why we are using 1500 bar now. And many engine, if you see new type of CRDi engine car, all those things, they are going 2000 bar, correct? So very fine droplets. So very fine droplets means because inside the combustion chamber, into the compression 400 4 easily evaporate. So the particulate matter will be in the CRDi engine. Main advantage is the particulate PM matter, PM will be less, correct? All the fuel will evaporate. All the fuel will evaporate. So there's the generation of particulate matter is very less. That is one thing, correct? In diesel engine using CRDi, common daily injection. For that, what you do is how the this one droplets is making fair. You have to inject the fuel at higher pressure, and while opening the injector and closing injector, that time only the pressure drop happens. Correct? Even though you pressurize to 1500 bar, if you open and close during that, there's a pressure drop happens. That pressure drop leads to bigger diesel droplets, because that the particulate matter generated, because they don't, diesel droplet doesn't evaporate fully, partially burned under. So for that, what you do is you put the fuel. You have here, you can see that this, you can see that you have the fuel tank, correct? There's a fuel pump inside tank. It pumps like any of this one. The fuel is pumped. There's a filter to remove dust, because this is the injector. Injector has nozzles, correct? Nozzle holes in the injector, which is in the order of micrometer size, micrometer dia, correct? 20, 50, something like that, depending on how much quantity you inject, correct? All the injector. So that means the fuel, the diesel fuel, any dust is should remove. Then it goes to a high pressure pump. Correct? You can see that high pressure pump. This pump pressurizes the fuel, diesel fuel, to 1500 or 2000 bar, around that, correct? Bar pressure. So the pressurized fuel enters into a big tube, correct? A cylindrical tube where it is stored. This is called as common rail. It is called as common rail, correct? So now from the common rail, you can see it is marked in red color, correct? Pressurized fuel, which is 1500, is given a red color, that is connected to individual injector. This is a 4-cylinder engine, correct? This is a 4-cylinder, each engine, each cylinder is an injector. So you can see that high pressure fuel, which is stored in the tube, metal tube. This is a metal tube. Please note that this metal tube should withstand 1500 bar to 2000 bar. For your information, India, nobody is making this, even the common rail. We are still importing. correct? Even now, all company, Indian company which is using common rail injection system, they are importing this from Germany, Bosch, something like that. All are imported. Indigenous, nobody is making the common rail because the pressure is so high, it can just burst and main accident can happen, high pressure, correct? All this tube. Okay, that is one thing. The injector also nobody is making in India, correct? You know the Bosch, they are leaders, and of course many Japanese companies, as Denso, one company is there, correct? Denso is a Japanese company, is a German company, like that. Many MA and many companies are, of course, Caterpillar in USA is making, correct? This common rail injection, rail as well as injectors, correct? Of course, Siemens is making injectors. Okay, so the high pressure is connected. Now there's a ECU, like port fuel injection here. No, high pressure fuel comes and waits here, correct? Whenever fuel has to be injected, ECU gives a pulse, again voltage pulse, 12 volt pulses, correct? So normally it will be 0 volts. Whenever fuel inject has to go, ECU will give the injection pulse when during the end of the, just before the end of the compression stroke. Instead of giving spark in SI engine, fuel is mixed during suction stroke. Spark is given at the end of the compression stroke, so many degrees before the TDC. So the combustion happens, the torque is produced. In diesel engine, pure air is circulated inside the engine during suction stroke. No fuel is added, and the inlet valve closed, exhaust are already closed. Compression happens. Fuel is compressed 15 to 18 times. So when the piston goes closer to the TDC, few degrees before this, correct? The fuel is injected. That is called start-up injection. That is called start-up injection in diesel engine, correct? So fuel will be injected few degrees before, 20 degrees, 30 degrees, 40 degrees, or 10 degrees before, depending upon engine speed. Again, correct? Again, this one, to burn the diesel fuel with air, correct? It takes a finite of the combustion time. It is called as combustion duration and combustion time, correct? Combustion duration of diesel fuel depends upon the fuel and the compression ratio, all these things. But again, it is fixed. It can be 1 millisecond, 1.5 millisecond, just like petrol. So you have to give sufficient time so that the fuel will burn. Again, just like your diesel engine, petrol engine, the piston is moving up. When the piston comes to TDC, 50% of fuel should be generally, this is a thumb rule, correct? At least 50% of fuel should have been burned. Then only the maximum pressure will be created inside the combustion chamber. It will push the piston down, correct, with a force, the hot gas. Then it will be converted to a torque in the crank mechanism. You get maximum torque. We know that both petrol engine, diesel engine is a torque machines. So they have to produce maximum torque by burning fuel fully without wasting, and so you will get maximum fuel efficiency, maximum torque. That happens only when you give sufficient time for the diesel fuel to mix with the air and evaporate and burn, correct? So that means you have to inject the fuel so many degrees before TDC, before the piston reaches TDC, correct? That is equal, depends upon the combustion duration. Combustion duration is fixed for diesel fuel. So depending on engine RPM, again you have to inject the startup. They call SOI, correct? Startup injection. You have to inject the fuel 30 degrees before. If the engine is running at 3000 RPM, correct? Correct. You say that 30 degrees before, correct? The TDC, you have to start the injection, correct? Fuel is started in the injector, start opening, correct? This is startup injection, correct? Startup injection, SOI, correct? Inject is open. Inject open how long? For the time needed to complete injection, and so that all the fuel is injected sufficient quantity, and that also completed before the piston reaches TDC during the compression stroke. So this is called end of injection, this one, correct? End of injection. EOI, SOI and EOI, startup. So this is the injection pulse duration. Again, this is a pulse width modulation, correct? This depends upon how much fuel you have to inject. That depends upon the engine power requirement, and that also depends on what is the pressure at fuel is injected, correct? All those things you have to, again, you have to make a lookup table, just like your petrol engine, correct? Petrol engine also you made a lookup table, correct? Fuel injection map. Same thing you have to do for diesel engine also. For different engine speed, different throttle condition, you have to this injector opening duration. We call pulse width modulation. That you have to do by connecting your diesel engine with dynamometer and set the throttle at different position, run the engine different RPM, fill the table and store it into ECU. Correct? Same as petrol engine. So that's what we are doing here. Okay. So now multiple cylinder means you will be putting multiple injectors. So that is called a common rail injector. Correct? System, common rail injection system. Correct? So the main why the common rail advantage, before I close this, what I want to say is, if I know you, I told you that when you inject the fuel, correct, when injector opens, there's a pressure drop happens, correct. During the start of injection and end of the injection, at the tip of the, okay, so here there's a pressure, because outside this is inside the combustion chamber. When you do compress, the pressure may be 30 to 40 bar or 50 bar compressed air just before TDC, correct? So this is my combustion chamber, piston is moving up, correct? The pressure compressed air fuel is around 40 bar. So if fuel had to be injected, the fuel pressure should be higher than the air pressure, correct? So that's why we are injecting around 1500 bar. When we open the injector, there's a pressure drop. Inside the fuel pressure is 1500 bar, outside 50 bar. If injector is not open instantaneously, correct? So you are giving a pulse, correct? This is SOA, start of injection. You are giving 12 volt pulse to injector, correct? 12 volt pulse is before the 0. If injector doesn't open instantaneously, correct? If this injector doesn't open, suppose injector opens slowly, correct? What will happen? There's a pressure drop happens. If pressure drop happens, the fuel will not become atomized in better. So the droplet size will be bigger. Fuel droplet, diesel fuel droplets will be bigger because of pressure drop, correct? So if I want to avoid pressure drop, what I have to do? I have to open the injector instantaneously, 0 time. This is a time axis, correct? This is 0 time. The injector should, even if you give the pulse, injector is a solenoid, correct? Injector is a solenoid, is a first order system, correct? So it takes some amount. So the current should flow and it magnetizes just like the petrol injector. Then only the current is moving like this is I. This is my voltage. So current is so magnetic field. So injector opens slowly. Correct. If injector opens slowly, pressure drop happens. Fuel will not atomize in better way. Bigger fuel drops will come. Then you will get more particulate matters. Similarly, when injector is closing, correct? Inject also, we want injectors to instantaneously. But actual injector being a solenoid, even if you stop the current will drop slowly, being an inductor. Inductor. So the current is slow. So that means there's a magnetic field. Injector close, it takes some amount of time. See, opening, it takes some time, closing also. During this time, there's a pressure drop happens. Because of pressure drop, what happens? The fuel will not become better droplets. Correct? So bigger droplets will come. That will generate bigger droplet means particulate matters. Correct? So that's why in CRDi engine, we are using instead of using conventional solenoid injector. Correct? Using conventional solenoid, now they are using what you call as piezo injectors. Piezo injector can open the injector in microseconds. Solenoid injector takes milliseconds, at least 0.5 millisecond, 0.1 millisecond, something like that. So you will see the pressure drop happens. Fuel will be fuel droplets will be bigger during the start of the end of the injection. To avoid that, they are using piezo injectors instead of solenoid. They use piezo injectors. They are very popular in common rail injection. Correct. Then another thing is, if you are using this common rail, because you are going to inject fuel quantity, correct? Each, for example, you are injecting say 50 milligrams of fuel, correct, in diesel injection, correct? Each injector, there are 4 injectors. You know that at a time only 1 injector will open in even multi-cylinder engine. After that, next cylinder open, the sequence like that only happens, correct? But the common rail will be able to store maybe 500 milligrams or 1000 milligrams of the fuel, or even more, correct? 10 or 20 times more fuel in the common rail. Okay. When you take small quantity of fuel from the reservoir, this is nothing but a fuel reservoir, correct? It is a fuel reservoir, correct? So it is now stored a high pressure by the pump. Now, from say 1000 milligrams, if you take 50 milligrams, how much fuel are you taking? Only 20 times less. Then if you take less fuel from your reserve high pressure one, the pressure drop will be less, correct? So the pressure drop 1,500 bar pressure will be close, it will be maintained. Of course, there will be when injector opens, because outside this one there will be a small pressure drop, but the pressure drop will be less because you are taking small quantity of the fuel from a bigger reservoir which is holding 1,000 milligrams of fuel. Correct? Out of that I'm taking 50 milligrams or 20 milligrams. So the pressure drop will be less. So that means we will have, when there is no pressure drop happens, correct? What will happen? The fuel will be injected at close to higher pressure. So better atomization. That is the reason for we are using common rail injection instead of using unit injectors. Correct? So this what happens. So again, if you see here, I want to close the engines today, and just two more slides. Correct. So you have ECU. Correct. This is a multi-cylinder engine, 4-cylinder diesel engine. Correct. You have a common rail. From common rail, as I told you, this is the tank. This is the filter. There's a pump. Sucks the fuel at 1 bar pressure fuel, which is atmospheric, and filters the fuel. Goes to high pressure. Here 1,500 bar fuel. That fuel is stored in the common rail to, as I told you, which avoids the pressure drop at the injector end. Because here more fuel is stored, only you are taking less fuel and individual injector that is connected to high pressure this injector. The injectors are controlled by pulse width modulation. Correct. So each injector will be opened separately. Correct. Next injector. So the first cylinder, second cylinder, third cylinder, fourth cylinder. So this is the pulse. So the duration of is pulse width modulation, just like petrol engine. By controlling fuel, you can control the amount of fuel injected in engine. So injection happens. This is it. But nowadays, one more small issue in diesel engine is, you'll see the diesel engine always make more noise. Correct? Diesel engine produces more noise compared to petrol engine. While engine is running, more noise. Correct? Why? Because diesel, when fuel combustion, what you call it, diesel combustion noise. It is called combustion noise. Correct? When fuel is burning, it makes some noise. You can't avoid when fuel burns. Correct? If the combustion happens in diesel engine, more compared to petrol. Correct? Petrol easily evaporates because the combustion happens because fuel is evaporating. You are injecting as a fuel inside the diesel engine, it evaporates and burns. Correct? Because of that only the combustion noise, all this happens. That's why diesel engine always make more noise compared to petrol engine, which cannot be avoided. Combustion noise is high. Correct? That can be reduced if your droplet size is made smaller. If the diesel fuel droplet small, that's why you're going to CRDi engine. Correct? In unit injector, the fuel injection is 300 bar, so droplet size 100 micrometer. Correct? If you go to CRDi engine, your injection pressure is 1,500 bar, and being a common rail is there, pressure drop doesn't happen. So when the 1,500 for inject fuel using the injector, correct? So the fuel drop may be 20 micron to 10 micron, which is much lesser the unit in which is this one. So when combustion happens, smaller droplet size, correct? The combustion noise reduces. That's why latest generation CRDi engine, you will see that it is very noise is very smooth. Correct? You won't get much noise. It may look even if you see a new CRDi engine. Still there will be a little noise compared to petrol, but it is not like old unit injectors. It will be similar to petrol engine. Correct? Combustion noise also can be reduced by CRDi because the fuel is injected at very high pressure, because fuel is stored in bigger reservoir and small quantities injected injector. That is the common rail advantage. But apart from that, instead of injecting all the fuel in one time, in common rail injector, you will inject multiple times. Correct? They are called sequential multi-fuel injection. First, for example, you have to inject, say, 100 milligrams of fuel. Correct? So instead of doing one injection, correct, one pulse, you can in the CRDi engine, they will give 3 or 5. You can see that in this figure, they are giving 5 pulses. Correct? Fuel is injected 5 times within the compression stroke. Correct? Instead of doing. So first called pilot fuel, very small, maybe 10% of the fuel. Correct? 10 milligram alone injected, one pulse. All this thing is happening during a compression stroke in diesel engine CRDi. Correct? 10 milligram. So that again, fuel is injected same 1,500 par. So less fuel, but inject a high pressure. So they evaporate, combustion starts. After combustion started, then you give another, say, another 20 milligrams. Correct? 20% of fuel. That is called pre-injection. Pilot injection 10%. For example, I'm saying it can be different. Correct? Then the fuel is very small droplet, they start burning. So combustion temperature already increases from 400 degree. Since fuel is burning, it may go around 80 degree. After some few microseconds, right, you inject the pre-injection 20%. So this fuel will evaporate much easier compared to this one. So diesel injection, because droplets is small, already high temperature or 800 degree combustion happening. So this fuel will evaporate easily. The combustion noise reduces. Okay, then you inject main fuel, maybe for example 50% or 60%, correct, as a third pulse, correct. After that you inject another 30% as after injection, correct. So when the piston is going down, correct, when piston is going down during a power stroke, so you inject fuel in multiple quantity, so the fuel droplets will be smaller and the temperature will be easy, all the diesel fuel will evaporate, correct. So this is called multiple injection, sequential injection, correct. This is also possible in common rail injection, which avoids what advantage? Less particulate matter. The injection in high pressure, you are injecting this one, and less combustion noise, diesel combustion noise. Correct. These are advantage of diesel injection. Correct. And the main thing, another one is, I will take 2 more minutes. I will complete. Because next class I wanted to go steering, because we are taken spend more time, but it will be useful. In the diesel engine, main problem is NOx, NOx. Correct. Nitric oxide creation. Why? The diesel engine combustion temperature very high compared to petrol engine. So I told you, if temperature of the combustion chamber is more than 1200, more NOx will be created. Correct. So in diesel engine, NOx creation is more compared to HC and CO creation. So so how to solve the NOx creation? For that, what they put instead of three-way catalytic converter, which was used in petrol engine. Correct. Here, what SCR? This is called SCR, selective catalytic reduction. What you do is, in the tailpipe, when in diesel engine, in the exhaust, this one, what you do is you put the SCR, they call electric. You inject urea, correct? Urea will be injected, and urea will be injected, correct? Urea will be injected along with water mixing. That will react with NOx, and it automatically converts N2 and this one. So that is called SCR, correct? Selective. So because that will be connected here, correct? And apart from that, you will have particulate filter, PM filter, correct? So you will have SCR. SCR, what we are doing is, in the exhaust gas, because you see the exhaust gas is coming out in the exhaust pipe, you inject urea, correct? Urea will react with NOx, and it will split to NOx into N2 and O2. O2 will mix with the carbon, this one will become CO2. So N2 will be inert. So that is called selective catalytic reduction. This is what used in diesel injection. And of course, you will have particulate matter filter also, another thing, correct? So remove the any dust particle, that's what is shown here. You can see here, SCR, correct? SCR and the particulate filter. This will be put in the diesel engine. With this, we'll stop engine. Next class, we will see about the steering and braking, ABS. How to control the brakes electronically using ABS, and also steering control. I'll stop here. See you tomorrow. Thank you very much.